Okay, class, welcome back to our problems of the day cheat sheet, week 4. We're on page number 3, learning target. I can use key features of a parabola to solve problems in a real world context. So our next problem, we see that we have a Air Force pilot flying at a cruising altitude of 9,000 feet. And the function that models their particular ejection from the aircraft can be seen in the following equation that I'm highlighting. All right. Now the question, the key term that we're trying to figure out is A, what is the vertex? And explain what the second coordinate of the vertex means. And B, the maximum number of feet above the aircraft is cruising altitude, and to justify the answer. All right, so you're going to turn off the video, take a couple of seconds, minutes, whatever you need, get your calculator going, and I'll be back after you had a chance to work on it. Okay, class, welcome back. Well, I hope you've had ample time to put it in your calculator and get the figure that I have in front of me. So there's a couple of things that we can, kind of pay attention to. Is first and foremost, well, the Y represents the maximum height that the pilot approaches. So what we have basically challenged you to do is to remember how to get our vertex by using the simple idea of, instead of focusing on intersections, let's focus on second trace, but instead of doing the 5 for intersections, let's do the maximum value. So our maximum value is 4, and then we got to kind of set some parameters. What we know that is going to be between 0 seconds, and let's say, let's just use 6 as around them 6 seconds. Okay. All right, between 0 and 6 seconds, and let the computer guess on what it is. Okay, so we find that in 4 seconds, our maximum altitude is going to be 9,256. So for us, as maximum height is what we need to write when we say, after the pilot was ejected, what is the value? So, okay, summarize. The second coordinate, the Y coordinate, represent maximum height. And the context of this is we are 9,256 feet above the ground. So let's take a look at the next question. The next question is, if I'm looking at this expression of -4, 9.9 x squared plus 50x plus 2, it's wondering, well, what's my initial height? What's my initial height? And what I'm hoping is that we are remembering that that final number is our y-intercept. And our y-intercept is always going to determine what we do initially. So in this case, 2 should have been a giveaway. Okay, gotta think about this now. It's question 2. A swim team member performs a dive from a springboard. The parabola below shows the path of her dive. You're going to turn off the video and take a couple minutes to think about these 3 questions. How high is the diving board? How far do they dive away from the diving board? And which interval is the diver's height always decreasing? Take a couple minutes. Okay, class, welcome back. So how high is the springboard that they're diving from? So, well, if we take a look at our graph here, we can see that everything kind of starts right here. That's 12, that's 16, so 14 the initial height is 14 feet. How far away is the springboard from when they hit the water? Well, the graph tells me that I'm starting at 0. I'm starting at 14. I get to my vertex and I hit the water right here. That's 8 feet away from our springboard. And the question of when am I always decreasing? Well, this is my vertex. From here to 8 seconds, I'm decreasing. So what is my vertex? Well, I know by looking at the graph, I'm going up 23 and I'm going over 3. So in 3 seconds, and I'm at 23 feet. And from 3 seconds to 8 seconds, I'm decreasing. So I think it's a safe bet to say that number 2 represents that the best. Okay? All right? It's also important to remember when they ask for vertex that when we know our vertex, we also know our angle of symmetry, because our angle of symmetry is just our x value of our vertex. Okay? All right. So, pause the video, get what you got to get, and come on back for the next page.